Today we're talking about section 8.9, which is the last section related to this chapter, and it's an application. So we're applying what we've learned in the previous sections to Pythagorean theorem and the distance formula. So you may have heard of the Pythagorean theorem from another class. We will be using it along with the skill set from working equations with radicals to help us do the Pythagorean theorem. Now, distance formula might be new. All right, let's first recap the Pythagorean theorem. So Pythagorean theorem is used for solving right triangles. And so on a right triangle, obviously we have the right angle in the corner. The two sides that are not the longest are referred to as legs, and they don't have to be the same size. Mine just kind of look the same length, but they can be the same or not the same. The longest side is the hypotenuse. Sorry, you can't really see that, but it says hypotenuse. Okay. The hypotenuse is the longest side, and if we are assigning letters to it, they typically assign the letters A, B, and C, with A and B being the legs and C being the hypotenuse. So the Pythagorean theorem, I'll make my pen a little smaller here. The Pythagorean theorem says that you can take the square of one of the legs plus the square of the other leg, and it will equal the square of the hypotenuse. Okay? By adding together the square of the two legs, you will get the answer as the square of the hypotenuse. All right? So what they're going to do is they're going to give us some problems where we know some of these values and one of them we don't, and then we'll use our skills to solve for the missing term. Here we go. On example 8.9a, I'll slide this up a little bit. 8.9a says find the length of the hypotenuse in a right triangle if the lengths of the legs are 4 and 8. So they're giving us that one of the legs, we'll call it A, is equal to 4, and the other leg, we'll call it B, is equal to 8. And we're going to plug it into this formula. So we're going to say 4 squared plus 8 squared should equal C squared. All right, well, we will then square 4. 4 times 4 is 16. 8 times 8, 64, would equal C squared. We would go ahead and add our 16 plus 64, and we get 80 is equal to C squared. Now, our goal is to solve for C. C squared is not enough. We got to get rid of the square on there. And we've learned that the opposite of our square is the square root. So we can take the square root of both sides, and it will cancel out with the square. And we'll now be left with just C. And then our square root of 80, we can reduce that. It's not a perfect square, but we know we can divide 80 by 4. Let's see. Actually, no. We can divide it by 16. And then take the square root of 16, which is 4. And then we have our solution for C. C is equal to 4 square root of 5. Okay? Technically, we would get a positive or a negative answer. So in your book, you may see a symbol that looks like this. That's equal to plus or minus that. Because we're dealing with, an actual triangle, we're going to forego that and just give the principal root of just 4 square root of 5. All right, let's look at the same thing, but instead of us looking for C, this time they're going to have us look for a different letter. So this is example 8.9b. And it says, find the length of one leg of a right triangle if the length of the other leg is 8 and the length of the hypotenuse is 17. So one of the legs, I could have picked A or B, is 18, but the hypotenuse, which the hypotenuse is always C, they're telling me it's 17. So we're gonna plug it in and solve for the piece that we don't know. So we have 18 squared plus B squared equals 17 squared. All right, so then we would calculate it. You would find out 18 squared, oops, I wrote it down wrong. It's 8 squared and 17. No wonder it looks different. Sorry guys. Let me fix that really quickly. I was gonna say these numbers were gonna get really big. Alright, so it's really just 8 was the original question. Okay, back on track here. Now we'll square 8. 8 times 8, 64. B squared is still B squared. And then 17 squared is 289. Alright, our job is to solve for B squared, so we're going to subtract the 64 on both sides. Hopefully this purple looks okay. I know reds and other colors have been doing weird things on the screen. Alright, so we got B squared, and then we subtract, you're going to get 225. Lastly, we want to get just B, not B squared. We'll take the square root of both sides. And we know that B is now equal to plus or minus 25, or in this case just, oops, not 25, 15. Yep. Alright. I apologize in advance for the noise in the background. They are doing recess right now as I'm recording this video. Okay. Now, let's talk about the distance formula. So the distance formula is a formula that's used to find the distance between 2 points on a graph. So going back to our Cartesian plane, and ordered pairs, and figuring out, what's the distance between 2 points. So we're not talking about slope, like how steep it is between the 2 points. We're talking about how far away is it, okay? And because you've got ordered pairs, there's a special way that we calculate that distance. All right, you can of course look in your book and see kind of a visual of what that looks like on the graph. But I'm gonna go right into the formula. Oops. Alright, distance formula looks kind of scary just before you actually see it. Let's see. It says that D, which is the distance, is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, okay? And in your book, they'll kind of explain a little more about how they came to this particular formula. It's similar to what we do with triangles when we're trying to find the distance between 2 points. Like if I've got a point here and a point here, I know this is the actual line that maybe goes between them, right? But if I want to find the distance from this point to this point, I'm going to have to, include the distance, in this format. So if I know how far it is from here to here, and I know how far it is from here to here, using a form of our Pythagorean theorem, I can then find the distance here, which is like our length. So again, the book kind of explains that a little better, but this is kind of where it's coming from. I just want to show you how to use the formula. All right, here we go. So the x sub 1s and sub 2s and on the y's as well are kind of like when we did our slope formula. It just means the second x and the first x, the second y and the first y. So these are not exponents, they're just labels, all right? and their labels for our ordered pair, they would have to give us, an x value and a y value. So we'd have an x, x and a y, and then a second x and y for the 2 points. And then we kind of say, okay, this is the first x, this is the second x, this will be your first x, second x, first y, second y, okay? But again, they're writing those little numbers down below, okay? All right, here we go. So the first example of using the distance formula, it says find the distance between the points 5, 4, and -2, -1. All right, so the first thing we notice, we know our x and then our y, x and then our y. This will be our x1, this is our y1, this is our x2, this is our y2. And we're going to plug these values into the distance formula. All right, so we've got our distance will equal the square root of our second x, which is -2, minus our first x, which is 5, then we'll square it, plus our second y, which is -1, minus our first y, which is 4, and then we'll square it. All right, so we've got -2 minus 5, it's going to give us a -7. -7 squared will give us a positive 49. -1 minus 4 will give us a -5, and -5 squared excuse me, is a positive 25. All right, we would add these together before we take the square root. So we'll get the square root of 74. 74 is not a perfect square, and 74 does not contain, or it's not divisible by any perfect squares. So our answer for the distance of between these 2 points is the square root of 74. Okay? Now, of course, there will be times when you can simplify, and of course we then should simplify if possible, but in this case we are not able to. All right, so in the assignment there'll be some questions like with this situation where they may have you find the missing letter in the Pythagorean theorem, or they're going to give you 2 ordered pairs and ask you to find the distance. All right, it's possible they may give you the distance and ask you to find a missing value, but they may not do that in this section, okay, because they're just kind of applying it for what you've learned so far. All right, we'll talk about it more in class.